It's a discovery big chunks of the scientific world had been waiting for, finding a new subatomic particle that could bring fresh understanding to how the universe works. The announcement brought applause and cheers and standing ovations and a special hand for Peter Higgs, the Scottish physicist who predicted the existence of such a particle back in the 1960s.
For almost 100 years, we have known that the universe is expanding. And we have traced its expansion back in time, through to the very beginning, when the universe occupied an infinitesimal point in space. This was the state of the universe at time t equals 0, over 13 billion years ago. It is from this starting point that everything we are familiar with came into existence. Protons, neutrons, stars, galaxies, even space and time itself are here. At time t equals 0, this point began an unprecedented inflation. In this instant, time and space were born. And this event has become known as the Big Bang.
Some 15 billion years ago, our universe began with the mightiest explosion of all time. The universe expanded, cooled, and darkened. Energy condensed into matter, mostly hydrogen atoms, and these atoms accumulated into vast clouds, rushing away from each other.
Less than a billionth of a second after the Big Bang, a bubble much smaller than a fraction of an atom forms. This is the universe. It is unimaginably small and unimaginably hot. Within this bubble, the four known forces of nature, gravity, electromagnetism, plus the strong and the weak nuclear forces, are a combined superforce. Gravity suddenly splits off from the superforce as the universe expands. As the universe expands, it cools, which somehow sets off a burst of energy, fueling the hyperinflation of the universe, suggested by Alan Guth. This inflation locks in the uniformity of the universe pictured by the WMAP satellite. The universe is still less than a second old when the superforce decays into the separate forces of nature. Roughly 3 minutes after the Big Bang, the temperature of the universe has dropped to a mere 1.
This Big Bang that they're looking for never occurred in the first place. It's absolutely ridiculous. It has been the bane of cosmology for at least 3 decades. It's absolutely absurd that the entire universe was an infinitesimally small point of super dense, super hot something and just blew up, creating the entire universe, planets, stars, everything that exists in the universe sprang from nothing. It's an idiotic concept to start with and makes absolutely no sense whatsoever.
It is a universe governed by laws and forces that literally hold our planet Earth and the entire cosmos together, and are finely calibrated to allow for both complex life and scientific discovery.
If you didn't have something like gravity that pulled matter together, you would never get planets, you wouldn't get stars, you wouldn't get any complex organisms. If you didn't have the strong nuclear force, there would be nothing to hold protons and neutrons together in the nucleus. And so you wouldn't have any atoms, so no chemistry. If you didn't have the electromagnetic force, you would have no bonding between chemicals. You would have no light, and the list goes on. So you need all these sorts of fundamental principles have to be in place in order for life to occur. Wipe out one of those principles, wipe out one of those laws, no life.
During the past 40 years, scientists have determined the relative strengths of each of these primary laws and forces. These strengths are so critically balanced, they are often described as being finely tuned.
If you're to take the basic fundamental constants of nature and you were to change these even slightly, or you were to pick their values at random, you would almost never get a universe that would be habitable in any sort of way. That is, you couldn't have galaxies, you couldn't have planets, you couldn't have complex biological organisms if these fundamental constants were even slightly different, slightly stronger, slightly weaker than they actually are in this universe. That's the idea of fine-tuning.
To better appreciate this concept, imagine a machine able to control the strengths of each of the physical constants. If you changed, even slightly from its current setting, the strength of any one of these fundamental forces, such as gravity, the impact on complex life would be catastrophic.
If you increased it by a little bit, no large-scale life forms could exist. Anything that was more than the size of a pea would be completely crushed.
For example, the strengths of the other forces are all important, the masses of the various subatomic particles. If all of these things were even a little bit different, then life, certainly life as we know it, could not exist.
These forces and constants are another example of the correlation between life and discovery. For not only are they finely tuned for our existence, they can also be understood.
It's remarkable how well the laws work, and not only that, it's remarkable how simple they are. And that also is related to the discoverability of the laws.
Albert Einstein wrote, "I have deep faith that the principles of the universe will be both beautiful and simple." For nearly 400 years, scientists have discovered an elegant simplicity in the mathematical equations that express and unlock the laws of the cosmos.
It's been said that many of the most important theories in theoretical physics can be written on a single sheet of paper.
Because what may be known of God is manifest in them, for God has shown it to them. For since the creation of the world, his invisible attributes are clearly seen, being understood by the things that are made, even his eternal power and Godhead, so that they are without excuse.
And this, I think, ought to be considered surprising, that such a simple formula or equation could have such far-reaching applications to a very complicated and very large universe.
In the beginning God created the heaven and the earth, and the earth was without form and void, and darkness was upon the face of the deep. And the Spirit of God moved upon the face of the waters.
The exchange particles of the weak force are the W and the Z boson. The weak force explains the energy production in the sun and is responsible for the radioactive beta decay. The electromagnetic force acts on charged particles. The corresponding force carrier is the photon. The electromagnetic force is responsible for propagation of light or for the fact that a magnet can pick up a paperclip. The strong attraction acts on the quarks.
And God said, "Let there be light," and there was light. And God saw the light that it was good, and God divided the light from the darkness.
The corresponding force carrier is the gluon. The gluon literally glues together the quarks in the neutrons and the protons, and it holds the nucleus together.
And God called the light day, and the darkness he called night, and the evening and the morning were the first day.
The Standard Model is extremely successful, and it has predicted all the phenomena we have seen so far at the microscopic level.
And God made two great lights, the greater light to rule the day, and the lesser light to rule the night. He made the stars also. And God set them in the firmament of the heaven to give light upon the earth, and to rule over the day and over the night, and to divide the light from the darkness. And God saw that it was good. And the evening and the morning were the fourth day.
It is self-consistent, it's predictive, but it's incomplete. There's one last missing piece of this puzzle. That's the Higgs boson. It's the holy grail of particle physics.
We know exactly what it should look like, and we have predicted this particle since over 40 years, and we use it in all our calculations and so on. We're pretty sure it's there, but we haven't found it so far. And now the LHC, which is already running, taking data, will find this particle if it exists. So this is the final piece of the Standard Model that we're looking for right now.
But thou, O Daniel, shut up the words and seal the book, even to the time of the end. Many shall run to and fro, and knowledge shall be increased.
Well, I would like to add my congratulations to everybody involved in this tremendous achievement. For me, it's really an incredible thing that it's happened in my lifetime.
But those at the world's biggest atom smasher who've been heading up the hunt for the Higgs boson, seen as the key to understanding why matter has mass, are still unwilling to say for certain that is what they've seen.
As a layman, I would say we have it.
The studies that are going to be done by the LHC over the next months and years, they will tell us more about the physics of the universe in the first microsecond of its creation.
Scientists at the Collider on the Swiss-French border and elsewhere will now pounce on the findings to see what they mean for their theories and whether this opens the door to a new kind of physics. In the meantime, though, one thing seems certain: a lot more atoms will get smashed in the process.
By faith we understand that the worlds were framed by the Word of God, so that the things which are seen were not made of things which are visible.
The secret things belong unto the Lord our God, but those things which are revealed belong unto us and to our children forever, that we may do all the words of this law.